Good evening, all of you. I welcome you all to the NEET crash course by Fiji Medical. Fiji Medical is nowadays a very common name known to everyone, but its journey started around 8 years back. Fiji is already a well-known name in the coaching industry, and consecutively for second year by the leading India Today group. So when we thought we need to also help the students around the states of Tamil Nadu and Kerala, Fiji Medical came into being. So right now Fiji Medical is running its medical, will be expanding to other parts of the country. So, you know, this year, when the pandemic, last year, in fact, pandemic hit, and many students who were trying to prepare for NEET exam, but not so bring this up to everyone. We associated ours labor of Hindu, Tamil, and we thought we'll give this, will make a crash course for NEET, but it's not a crash course. It's actually a course with prolong, which will be extended to the NEET examination. And this course has been divided into 6 modules. Each module will in itself will have biology as subjects, where several topics will be taken into them, and then you will have a module test for every module. See this whole so we talk about NEET. We thought the best LA this year is more NEET examination. NEET is going to stay, and everyone has to prepare themselves for it. Fiji Medical brings an excellent opportunity for all the students who are preparing for NEET to come for this course and prepare themselves holistically. Even if they have prepared elsewhere, this course will give them the required, the last minute brushing of all the concepts, plus the experience of testing. Even for those students who probably is not planning to write again for next year, for them this particular course will be extremely beneficial. Fiji Medical also runs programs for class 9, 10, 11, 12, and 12 pass students who wants to appear for NEET. So, a brief introduction about release. Now, is it the self-discipline or is it the exam temperament? If you have to point out one thing that can be pointed out, which is required to crack an exam like NEET, where you you have 180 questions in 180 minutes to solve one question per minute is very difficult. So for that, it requires a combination of exceptions would be that. Number two, you need ample practice of the same. A lot of practice goes behind, practice about this competitive examination, because finally, when it comes to solving the question, you require that time management skill, which will come only through your practice. Practice in time bound manner, keeping time and then practicing. Number three would be how you take up your examination, your exam temperament, how you take, which subject you should be taking first, which should be taking last. How do you approach a question which you cannot solve? Should you leave it? Should you try it again, or should you wait? You know. Till the time gets over and then come back, like you finish all the question and then come back to that question. So what should be your strategy? Which questions to be taken first, the easier one, the difficult ones? All these things you will be learning over here. This particular course will help you to build your concepts. This particular course will also help you to build your exam temperament. It will help you to realize your mistakes, what you have done. When you write a test, it's not the test that only matters, it's the analysis behind the test which becomes more important. So when you analyze, you find where you went wrong, what you had done, what should have been done. So those things will come only through a proper analysis of exam. So in our course, you also get analysis of the test that you write. So this full program is all about NEET. Here, every topic, every concept which will be asked in NEET will be taught. You will have tests, you will have assignments to solve, and you will also get analysis of the test. So this crash course is a program, a complete preparation for NEET in itself. So I would urge all of you to attend all the classes, to take up all the tests, and also ask your friends to join this course. Also ask your relatives and whoever you know who are interested in NEET. Need not be only the students who are appearing for NEET this year, but next year other courses. We have free NEET going to 11th and stay 8th going to 9th standard. And the next admission test for this free NEET coaching program is on 2nd of May. Please get the words, help the needy, who really deserve it. And we assure you that you will have a wonderful time with this course. All your concepts, the problems that you were facing will be taken care of. We also would offer you doubt sessions through emails. Like we will share certain email IDs where you can send your doubts and which would be cleared by the teacher and sent back to you. So wish you all the best. Have happy time in this NEET crash course, and here meet Mr. Satish Kumar, a physics professor.
Hello, sir.
And
Can you
he's
hear
an
me,
excellent
sir?
teacher with an experience of more than 10 years in NEET coaching. Thank you. Yes, 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 sir. So that's all from my side. Thank you.
Okay, sir. So I start with the class now.
Yeah, you can
Okay, sir.
start the class. Thank you, sir.
Hello, students. Good evening to all of you. Right. I hope all of you can hear me. And so I'm Satish Kumar, right, and here for this NEET crash course. And so today we are beginning with the first topic in physics, that is the vectors, and we'll keep progressing the topic with the topics one after the other. Right, so quickly let us go over the see what it is, go over the rules, right? And then we can do some problems which are asked in the previous year's NEET exam, right? So which will boost you the which will give you a lot of confidence on this topic. So let's start the topic straight away, right? Because we have a very limited time. So and I also suggest to all of you to be ready with a pen paper so that you can take down whatever is happening in a serious way. Great, sir. Okay, students, I was informed that I can talk in Tamil also. So, right, right, I'll go slowly only, right? And so we'll start with this vectors. So the first thing is what is vectors, right? And how is it different from one more quantity called scalars? Right? So in physics, they usually categorize this as quantities into two things here: the scalars and the vectors. We have. So what is a scalar, right? And what is a vector, right? So most of you must be knowing this the difference between these two things. Right? Scalars are quantities which has only magnitude. Right? Only magnitude alone it will have. Without specifying any direction. There is no direction associated with it, right? For example, if you say your mass is 50 kilograms, that's a scalar, right? Or if you say today's temperature is say 35 degrees, that's a scalar quantity, right? Or this computer has a capacity of say 1 terabyte, right? That's a scalar quantity. Like that, they're just a mere number, but without any direction associated with it. So those come under this category of scalars. So then what is a vector? So vector is something which is different from a scalar. A vector is something which has also a direction associated to it, like magnitude, and along with that it will also have a direction. Right? For example, if you say simply this car is going at 50 kilometers per hour, that is a scalar quantity. Right? If I say simply this car speed is 50 kilometers per hour, it comes under a scalar. Right? At the same time, if I say it is 50 kilometers per hour, right, in the direction of north, 50 kilometers per hour in the direction of north, it becomes a vector, right? Because how this 50 kilometers per hour, this magnitude is associated with the direction here, right? So it's a vector quantity now. So those are the main differences here. Where the scalars are quantities that have only magnitude, there is a vector has a magnitude and direction as well. Right? One more example. Suppose if you say, right, you walk 5 kilometers. Is that a scalar or a vector? So you walk 5 kilometers means 5 is just like we don't have any direction there. So it's just a scalar quantity. So this 5 kilometers is a scalar quantity. Whereas if you say 5 kilometers, you walk 5 kilometers in the direction of say west. Right? So this becomes a vector quantity. Right? So vector is something that will also have a magnitude. Right? What we say as magnitude is this 5 kilometer and also a direction associated with it. It's west or north. Right? There are more ways to represent this direction. Right? As we see, there are other ways. It's not always north is southwest, but there are other ways to represent this direction. We study that soon. Right? But in essence, that is what is a vector. It will have a magnitude and a direction. So now we will see some properties of vectors, right? Vector addition, subtraction, right? Multiplication. So these properties will summarize. We'll go through one after the other. First is so the addition of vectors. So before we go to addition of vectors, first of all we have to see about the representation of a vector. Before that, and then we will go to the addition. So representation of a vector. So if you have a vector, let's say This is a vector we represent like this. So this arrow will have a tail and a tail. This part over here is the tail. Tip and tail we call it. This is the tip and this is the tip and this is the tail. Okay. So the direction in which this arrow points that represents the direction of the vector, right? And the length of this arrow, right? So from here to here, the length of the arrow represents the magnitude. If you say, for example, this is a vector. So the magnitude of A is given by the length. We write like this. So this gives the magnitude of A. Right? So this is the magnitude of A. Right? So this is the magnitude of A vector, and this direction in which it points, that is the direction of the A vector here. So usually a vector, we use some representations like we put a letter and an arrow on the top, or sometimes in books they use bold letters to represent vectors. Like simply they use A, but they write it in bold form. That is also a vector. But we don't use that when writing. When writing, we use this form because we cannot write it in bold, like it will be difficult. So we use this form in writing. Right? So that's how we represent the vector. Vectors are represented like this. Now, addition of two vectors. How do we add two vectors? Addition of vectors. Right? So let's say there are two vectors now, right? Along with the A vector, let's say you have one more vector which is B vector. How will you be adding the two vectors? So right now, whatever the addition we are going to see, we call it geometric addition because we don't do any analytic things there. It is simply geometrically we add the vectors. So this sort of addition can be called as the geometrical addition of vectors. Whatever we are going to do. Right? Suppose if you have a vector, right? Let's say this is a vector, right? And you have another vector, let's say b vector. So how do you add these two vectors here? So the method in which we add these two vectors is like we place one vector after the other vector. That is, this is a vector, and you can place this b vector just at the tip of the a vector. Right? Right? Another important property of vectors is you can move it anywhere in space. Right? That privilege you have. You don't have to restrict it to one place. You can move this vector anywhere in space. It is fine completely as long as the magnitude and the direction remains the same, and it can be moved anywhere in space. So this vector can be moved in such a way that you are drawing it like this, so that the tail of the B vector is touching the head of the A vector. So this is A vector and this is B vector. Right? Now you join the tail of the first vector with the tip of the second vector, right, or the last vector. So this vector here. So this vector is, right, is what we call A vector plus B vector. These two vectors are separately A vector and B vector. Join the tip to the tail. Tail of the first vector to the head of the last vector. So this will be the addition of two vectors here. A vector plus B vector. Right. One more thing you can use, it is not that you have to add A vector to B vector. You can also add B vector to A vector. It is one of the very important properties of vectors that it is a commutative. Right. Vector addition is just a minute. I'll be back with a different marker. Next one. So sorry for the delay, but right, I just got this marker. So this is one way of adding this vector, like a vector, b vector, a vector plus b vector. The other way of adding it is that you can also add b vector to a vector. You can draw b vector first, right? Like this. This is b vector, right? And then the a vector, right? And then like this. So this is also. So the final thing is the same. Like whether it is a vector plus b vector, you can see that even in this diagram it is almost the same. The direction is the same. In both cases, the resultant is pointing towards right, towards the side, towards the left, right, and the magnitude also remains the same. Right? So the what way you are adding these vectors one after the other doesn't matter here. Right? It is as long if you add all the vectors, that is fine. Right? Whatever vectors you want to add, the order of addition doesn't matter here. So we can see that a vector plus b vector is equal to b vector plus a vector. So the order of this addition don't matter here, and this property of vector we call it commutative property. So this property of vector is called the commutative property of vector, which means what way we add. Right? This can be done for more than two vectors also. Here we need with two vectors. Whatever number of vectors that you have, right? Even if you have 10 vectors, 20 vectors, can be the same thing. You place the vectors one after the other inside the head. That the head of the first vector is joined with the tail of the next vector. Like that, you join one after the other, and finally you draw a line from the tail of the first to the head of the last. So that will be the resultant vector. So this is one property of vector. There's one more property also, right? That we say the associative property. Right? It means that how you group these vectors don't matter. I'll show you that also. So let's say there are three vectors now. So let's say this is a vector, b vector, right? And this is c vector. So there are three vectors we have taken. So now if you want to add all the three vectors, right? And the purpose is we have to add all the three vectors. I've drawn like that, like in such a way that we can add them. So what we can do is you can add these two first. Like this vector is now a vector plus b vector. Plus you can add c vector. So if you draw a line like this, so this means that this is a vector plus b vector. Right? So to this you are adding this c vector. Right? And one more way to do the same thing is you can add b and c first, and to that you can add this a vector. So I'm adding b vector and a c vector here. So this is b vector plus c vector. So this we are adding this a vector. If you do so, like that also will be the same. It will be like a vector plus b vector plus c vector. So the final outcome is the same. So it is this a vector plus b vector. You are adding these two first. To this you are adding the c vector. Right? So this is the same as adding b plus c to that adding a vector. So both are same. This is another property of vectors which says that it doesn't matter how you group the vectors. Right? So that is called the associative property of vectors. Right? So the associative property of vectors, which means the way in which you group these vectors don't matter, right? Suppose if you have three vectors, 1, 2, 3, right? You can group 1 and 2, to that you can add the third vector. Or you can add group 1 and 3, to that you can add the second vector. Right? So like that, the way in which you group doesn't matter. Right? So these are some important properties here, right, of vectors. The next is we'll move on to the geometrical subtraction. Subtraction of two vectors. Subtraction of vectors. So, as in any case, like we are not going to add, we are going to subtract. Let us say you want to do a vector minus b vector, right? So a vector minus b vector. This is what you want to do. Right? A vector, you need to subtract with b vector. Now we can also interpret this as a vector. To this a vector, you are adding minus b vector. So you can understand this operation like this: a vector minus b vector is equal to adding a vector to minus b vector. So what we are going to do is this. Suppose you have this the a vector like this, let's say, right? And to this you have to add this b vector. Right? Now, adding minus b vector to a vector, right, is same as doing a vector minus b vector. So now you have b vector. Now how do you generate minus b vector out of this? Right? So any vector can be considered as the negative of the other vector, provided it is just anti-parallel to it. It should be in the opposite direction. If it is initially pointing in this direction, it should be pointing in the completely opposite direction, but with the same magnitude. Okay? So this is b vector like this. So if you have one more vector like this, okay, which is exactly having the same magnitude as b, okay, but in the opposite direction. So this vector we call it minus b vector. Right? So all you can do is to this a vector, you can add this minus b vector for this subtraction of vectors. To this a vector, you are not going to add b vector, you are going to add minus b vector. Right? So you are going to add minus b vector. So this resultant, this is going to give you a vector minus b vector. Right, students? Right? So this is one way of seeing it. There is one more way also you can see this thing. So to the a vector you are adding minus b vector. Suppose you don't want to draw minus b vector, still there is a way to, right, to do it in a bit. So what you can do is you can draw these two vectors a and b. Right? What another similar way to do this is this is a vector, right, and this is b vector. B vector. So draw these things from the same origin, same starting point like this. This is a vector and b vector. Now, what we have to do is a vector minus b vector. So that is the operation we need to do. So if you put an arrow like this from b to a like this, right? So this is the sum of minus b vector because the minus b vector is pointing like this. Minus b vector to that we are adding this a vector. This is a vector minus b vector. Right? So this means that to the a vector you are adding minus b vector. Right, students? So these are the this is what is the subtraction of vectors. Right? I'll show you one more example also. Right? Suppose let's say you have two vectors c vector and d vector. Right? So that you should be able to differentiate that what we are subtracting with what. Right? Suppose there is a c vector like this, right, and a d vector like this, right? D vector like this, right? So suppose if I am drawing an arrow from here to here, right? So this way I am drawing an arrow. So this is what. So this means to this minus c vector, I am adding d vector, right? So this is then d vector minus c vector. Right, students? So at the same time, here d vector is like this, c vector is like this. But instead of drawing this arrow this way, if I am putting the arrow this way, right? So this means that to the minus d vector, I am adding c vector. So this is then c vector minus d vector. Right? So this difference you need to know, right? So both are same. C vector, d vector. This is also c vector and d vector only. But if you join these two heads like this, if the resultant is like this, means this is d vector minus c vector. But if the resultant is like this is c vector minus d vector. So this c vector, you are adding minus d vector. Here to this d vector, you are adding minus c vector. So that difference you should know here. Right? So that's about the subtraction of vectors. So whatever we were doing so far is called the geometric addition and geometric subtraction. Right? Basically, we use it to understand the basic concept of vectors. But this alone is not enough for us to do, right, the problems. Right? It will be very difficult, like always, to construct geometrically and do things. So what we have is a much better methods we have, right? And there we study we resolve the vectors into the components. So that gives us with an easier way to work some difference. Right? It makes things easier. So let's study that next. That is resolving a vector into its components. So resolution of a vector, or sometimes we also say resolving a vector into components. Both have same meaning only. Right? Suppose if you have a vector like this. So how to resolve the vector into its components? Right? For that, first of all, we need to define the components here. Right? So let us take the usual way, like this is our x and y axis. Let's say this is the x and y axis here. So that like we can resolve this vector into along the x-axis, and for now we will consider this as a two-dimensional vector. Right? In a general case, vectors can be on the 3 dimensions, but for simplicity we are considering it to be on the plane. Right? It is on this board, you can imagine. So this is a vector means if you just drop a perpendicular here on both sides like this. So this is ax. Right? This is the x component of the vector, and this is ay. This is y component of the vector. Right? Remember, students, this ax and ay are algebraic things. It can be negative also. It is not that it will be. In this case, it is positive, but this ax and ay in general case can be negative also. Right? And let's say this makes an angle of theta here. The vector makes an angle of theta with the x-axis here. Right? So what is ax and what is ay? Right? That can be found now. Right? Since we know theta, so ax is equal to a cos theta. Right? Right? Because this is the adjacent side, and this is the equal to, say, ax is equal to a cos theta, and ay is equal to a sin theta. Right? So that's what is. So these we say as the components of vector. Ax and ay as the components of the vector. So now the components itself have the we are studying that this vector has two information in it. Right? This vector has information on the magnitude and also the direction. Now this information is contained by this components itself. Right? Ax and ay has this information. Right? That is the magnitude. Now you know that since the Pythagoras theorem can be applied because this is perpendicular here, we can write down the magnitude of this vector. Right? The magnitude of this vector is a is equal to the square root of ax square plus ay square. So that's what is the magnitude of the vector. Now the direction also can be obtained from this components itself. Right? That is, if we only have to know theta, and that can be found because you know that this is ax and this is ay. Right? So you know the adjacent side and you know the opposite side. So what connects the adjacent side and the opposite side? So that is that way the tan theta. Right? So this is equal to ay and ay by ax. So a vector has two information contained in it. One is the magnitude and the direction, and those two information, both the information are given by this components here, ax and ay. The magnitude is given when you perform this. Okay? We can do this because these two components are perpendicular to each other, and the tan theta is equal to ay by ax. Here we have to be careful about the quadrant, right? Because sometimes the first and third quadrant can come, so we have to be sure on which quadrant we are doing. So this information is given by the components itself. Right? So this way we solve the vector into components. Right? But I think this is also not a very efficient method. For some problems it can be helpful, but a more efficient method is right assigning some unit vectors along these directions, along x direction, y direction, z direction. We assign some unit vectors, right? And we tell we represent the vector in terms of its unit vectors. Right? So that is most comfortable for solving the problems. Right? So to do that, first let's see what unit vector is. Right? When you say unit vector, what is that quantity? Right now, I hope so far I'm clear to all of you. Right, and so let's go on to the next quantity, which is the unit vectors. So this plays a very important role in vector, right? This particular quantity, unit vector. So suppose, right, let's consider a vector A vector. So what is the unit vector of this A? A vector is that. So what can be its unit vector? So as the name indicates here, unit. So unit means what? Right? Something which has which is associated with the number one. Right? So unit means the magnitude must be one. At the same time, it should point in the same direction as the original vector. Suppose if I am drawing a small vector here, like this, like this. So let's say the magnitude of this is 1. So magnitude is 1, but at the same time, this vector is pointing in the same direction as A vector. Right? So then we can say this vector as the unit vector of this A vector. So one thing is the magnitude must be 1, right? The measurement should give you 1, right? And it should point in the same direction as the vector whatever we are finding unit vector, right? And here there is a special convention for this unit vector. We write it like this. We put an A and we put a cap over this. This is what is a unit vector. This A represents this A cap here represents the unit vector. Right, students? So that's what is unit vector. So now we can write this vector A itself into in terms of this unit vector. So you know that there are two information contained in this one thing, which is the magnitude of A, and also this also has a direction. Now with the help of this unit vector, we can separate those two things. The magnitude and direction, we can separate it, and we can write like this. And write like this is equal to the magnitude of A vector. Remember, this is giving you the magnitude of A vector. But what it is missing is direction. So you can simply A cap. You can simply multiply with A cap. Right? So this takes care of the direction. Right? So this has magnitude and direction. So we are splitting that into magnitude part separately and direction part separately. Right? So we are multiplying only with 1. So no harm if you multiply anything with 1. But this is just to take care of the direction. This A cap is just to take care of the direction. Right, students? So that's what is the concept of unit vector. Right? That is a vector with a magnitude of 1, right? And it should point in the same direction as the vector itself. And this unit vector we introduce along all the three axes. Right? We know there is in a coordinate system there are three axes like the Cartesian coordinate system. X-axis we have, right? Y-axis and Z-axis. So there is unit vector for all those three. So there is x-axis like this. So x, y, and z axis we have. So there are right. We choose specifically some letters, some letters to represent unit vectors. So along x, we call it I cap. Along y axis we call it j cap. Along z axis we call it k cap. So these vectors are this I, J, K. They are unit vectors, right? I, J, K are unit vectors, but specifically they are in this direction. They are in the x direction, y direction, and also the z direction. What is it? We call it k cap. Right? So we stick to this. We always say along x it is I, along y it is j, and along z it is k. Right? So now we go on to do the same vector addition using this unit vectors, right? And we see that it's much more comfortable when it comes to solving problems. So with this knowledge, we go to the next part. Let us say you want to add two vectors, a vector and b vector. You want to do this operation, a vector plus b vector. Earlier we did this operation geometrically, right? Geometrical addition we do it, but as we know that practically we can solve problems like every time you need a graph, otherwise to solve it it's difficult. Right? So only we go for an analytical approach. So what is a vector plus b vector? How to do that? Now analytically, but we are going to make use of our unit vectors, what we learned now. So let us say right. So for convenience, once again I'll take two dimensions, right? So that it will be easy here. Let us say this is a vector here. To this a vector you are adding b vector. Okay. So to this a vector you are adding b vector. Right? So now let's resolve this into the components, right? As we did previously, we will resolve this into components. But one extra thing is we are bringing this unit vectors concept here, right? In resolving this, we are bringing this unit vectors concept. So now this a vector can be resolved like this. Right? So the components of this a vector can be written as ax into I cap, right? Right? Because along x-axis it is I cap here, so ax into I cap. And this component can be written as. So right now what we are seeing is the vector components, not just scalar components. We are seeing the vector components of a vector. Okay? That is different from the earlier one, which is scalar components of a vector. So this is x into I cap, and this is a y into j cap. Right? So like this, we have resolved the a vector itself into the x and y components like this. Right? So now we can write down a is equal to a vector is equal to ax into I cap plus ay j cap. So it just means that it is along x-axis. Right? This much. So this ax value will be something like it can be plus 2, minus 3, any value. It can be some numerical value. It says it is that much along x-axis. Right? Again, ay is a algebraic value here. It can be like minus 4, right? Plus 7, anything it can be. So, but it is in the y direction. Right? Similarly, you can add b also here. Right? So there is x and y component for this b. Right? So this is then b x into I cap, and this is b y into j cap. Right? Right, so that will be here over here. So this quantity here is bx into I cap, and this quantity over here is by into j cap. Right? You can move the vectors anywhere, like that privilege you have. So if this is bx into I, this is also bx into I only. So b vector is equal to bx into I cap plus by into j cap. So now the purpose is to add these two vectors. So how will we add these two vectors here? So we can write the resultant as some r vector. Let's represent the resultant with r vector. So I draw here. Right. So this resultant vector will be pointing from here to here, just like as in geometric addition. So it will point from the tail of a vector to the tip of b vector here. So let's call this as r vector here. And let us define this resultant vector r to be a vector plus b vector. Right? So we just have to add these two things now. Right? So now the advantage in writing down this component form is we can separately write it down for single components in one direction. Right? So we can add it like this. My vector is equal to, I can add all the x components together and all the y components together. It can be group ax plus bx into I cap plus ay plus by into j cap. So this way we can group the components here, right? So that's the advantage of doing it in this component way. So the resultant is given by ax plus bx into I cap plus by into j cap. So that should give you the resultant vector. So this way, it makes things simple, right? When we add two vectors, let's just do one sample and show you. Right? I'll show you like how this works. Let's do a sample problem. Right. So let's say a vector is 3 I cap plus 2 j cap. I'll go for the general case. In the general case, we also assume the third direction. Let us say minus 4 j cap. Right? And b vector is right, I cap minus j cap right, plus 6 j cap. Right? You can have more than 2 also. Right? Let's say c vector is just 4 I cap. Right? It is not must that you have to have all the 3. Right? Sometimes it can be in one dimension also. Right? C vector is minus 4 I cap. Right? So let's say we want to perform. Right, we can you can perform whatever operation you want with this ABC. Let's say you want to find the sum of the three vectors, a vector plus b vector plus c vector. So let's say R vector is equal to a vector plus b vector plus c vector. So just have to add this together. So let's add first all the terms that are in along x. So that will be 3 plus 1 plus 4 into I cap plus along j you have 2 minus 1. Right? And the third one you don't have any j here, so that will be 0. Right? And for the last one, so for this j cap, the last one you have minus 4 plus 6 and again 0 k cap. Right, friends? I hope all of you can see now. So this, if you simplify further, this further means you will have 8 I cap, right? 3 plus 1 plus 4 is 8 I cap plus j cap, right? 2 minus 1 is 1, so plus j cap minus 4 plus 6, that is plus 2, so plus 2 k cap, right? So this is what is the resultant vector, right? The resultant vector is given by this. So this way, resolving a vector right, into its vector components like this, right? Along x-axis, y-axis, z-axis makes things simple. Right? Algebraically, it becomes easy to work. Right? So not only this, you can perform other operations also. Right? This is just adding to vectors. But suppose if you want to do, right? So let's take up another problem where we have to find, say, what is 4c vector? Right? Just you want to find, you have c vector defined this way. What is 4c vector? Simply multiply this vector with 4. That's it. Right? So 4 times 4i. So that's going to be 16 I cap. So that's what is 4c. Likewise, you can perform multiple operations. Right? For example, you can also do like a vector right, minus b vector. This can be done. Right? Write down a vector, then minus 3 into this b vector. Right? So that will be the operator. Right? So likewise, you can perform right, multiple ways, like you can add and subtract things here. But with whatever we have done, we are only like doing addition, subtraction only. Right? And, scalar multiplication we can do. Right? So this is something we call it as scalar multiplication. We are just multiplying with a number that we can do. Right? 4 into 4i will be 16 like that. Right, students? So these are things with the vector additions, right? Addition and subtraction. Right. So let's move on to the next thing. We have to finish a few more things also. That is the vector multiplication. That also we'll see today. vector multiplication. Right? So sometimes you can't always add or subtract things, right? Suppose, and whenever you are adding or subtracting, you can only do with the like things. Suppose if you add distance, you can add distance to another distance only, right? You can add, say, velocity to another velocity only. Right? For example, I cannot add displacement with velocity. Right? That will become meaningless. Right, students? So that way, right, this multiplication is needed because what if you have to perform, you have to work with two different quantities, right? Then the product of those two can lead to a completely different quantity, right? So for such cases, the multiplication is needed. Right? When two things are different, you cannot do addition or subtraction. Right? We have to have some other operation. Right? So for example, one common example is the right. All of you would know the definition of work in physics. Right? How is work defined? We define it like work is equal to F vector dot d vector, right? Where this d stands for the displacement, or sometimes we also just put r vector here, F vector dot r vector, where this r stands for the displacement. We can write like this vector F vector dot delta r. So this is how we define the work in physics. Right? So the force we are doing the dot product with the displacement. Right? So this is so there are two such products involved here, right? One sort of a multiplication of this dot, we call it dot product, and there is a multiplication of another sort, right? Which we will call it as cross product. So I come to that after explaining this dot product first. Right? First, let's work on this dot product, and then we will go to the cross product. So as it means, it is the force F dot delta R. So that's what is the work done, right? And it's like this, students. Right? Suppose, let's say that I explain with one example, and then we can go to the definition here. Suppose if a block is like this, and a force is pulling the block like this. A force is pulling the block like this, and because of this pull, the block is getting displaced. Right? It is getting displaced in this direction. It is getting displaced in this direction. Let's say it goes till this point. The force is acting like this. Right? So now the displacement has happened from here to here, right? From this point to this point. So this is what is the distance displacement, which is delta r here. Right? So here what matters is, according to the definition of work, right? You all know that the work is given by Fd cos theta. Right? So it is the component of this force along the displacement. Right? Or you can also say the component of displacement along the force. Either way you can take it. So the component of force along displacement. So that we have to find. So that is what the dot product helps you to find. It just helps you to find. So it is defined to be F into F delta R cos theta. Right? So we can write like this. We can write like this: the magnitude of F, the magnitude of delta R, right, into cos theta. You can write like this. Right? So this is how it is defined: F magnitude of force, magnitude of displacement times the cos theta. Right? So this can be this quantity, as you know, the work can be positive or negative, sometimes zero also. But all that will be taken care by this theta. Right? If it is positive, means theta value will be accordingly from 0 to 90. Negative means also theta will be like beyond 90. Right? 90 exactly means it is 0. So this sort of operation only we call it dot product. To write down in words is the right. So you can say that it is like, if suppose the angle made with this delta R is theta here. Right? The angle made here is theta here. So it is the component of this force. Right? This is F cos theta. F cos theta, we are multiplying with delta R here. It is the component of the force along the direction of the displacement. Right? Or vice versa also you can take. Right? It is the component of displacement along the force. So one example I explained here, like we will do with some variables, right? To understand like this work is some quantity you have studied. Right? I started with this example. let's start with let's do like in a for a general case. So you're having two vectors here, A vector and B vector. So we define like this: A vector dot B vector is equal to A vector magnitude of A times magnitude of B into cos theta. Okay. So this is how we define the dot product of two vectors. Okay. So what it means is, suppose if this vector is A vector, right, and this vector is B vector. What this means physically is, like, you can interpret it like this. You can just draw a perpendicular here. Right, students? Where this theta is the angle between the vectors here. So this theta is here. So this becomes one A cos theta. This becomes A cos theta. So this length from here to here is A cos theta. Right? So what it means is, it is the product of dot product can be regarded as the product of magnitude of one vector, the product of magnitude of one vector with the component of the other vector in the direction of the first vector. Right? It's a bit long, but this is if you understand, like, that's what is the meaning of this dot product. It is the product of the magnitude of one vector. Right? For example, in this case, what we have done is, we have done this only. What we have done is the magnitude of B into A cos theta. Right? So this is what we have done. In this case, it is B, right, with A cos theta. That's what we have done. So the product of magnitude of one vector. The magnitude of one vector. This one vector is this B vector. The product of, right, in this particular case, B vector with the component of the other vector. So that is A cos theta. That is the component of the other vector. So along which direction you are taking this component? So this component you are taking along B only, not along any other direction. The component of A is taken along B here. That's what is holding first thing. With the component of the other vector in the direction of the first vector. Okay. So that is the product of one vector. You can choose any of the vector here. Right? In this case, we have chosen this B vector. It is the product of B vector. Right? With magnitude of one vector. The product of, so this gives the magnitude of B times, right, the component of the other vector. Other vector is what? A vector. Okay? The component of this A vector along B vector in the direction of the first vector. Right, students? So that is what is this dot product here. You can also do exact opposite. Also, you can also think of this as the component of A into B cos theta. This also is the same. So you can take A vector, the magnitude of A, then you multiply with the component of B along A. That also will give you the same thing only. Right? So basically, this dot product is commutative. Commutative means, like, which way you are doing this dot product. Like A dot B or B dot A, it doesn't matter here. So that's what is the definition of this dot product, students. You see some of the properties of this dot product quickly. So as we see here, you can do either. You can either multiply magnitude of B with component of A along B, or magnitude of A with component of B along A. So either of it you can do. So it means the order of this dot product doesn't matter. So that comes as the first property for us. So let's just erase it and write. That is A vector dot B vector is equal to B vector dot A vector. So the order doesn't matter for us. Whichever way you want, you can perform the dot product. So the next one. So some of the important properties I will write out here. Now you know that we are taking the product of one vector along the other vector, right? Along the direction of the other vector. So which means the quantity is like this. So I dot I. So what will be this I dot I? Right? And this the magnitude of I along I is 1. So that is along taken along I itself. Right? So that should be 1. Right? We can also prove this mathematically. This should be equal to 1. But it is also not to prove this mathematically. We can write this as magnitude of I cap into cos theta. Now this theta is going to be like, according to the definition of the dot product we are writing. So the magnitude of I cap is 1. This is also 1. What is cos 0? Why we are putting 0 is both vectors are pointing in the same direction. Right? Both I cap, right? Both will point in the same direction like this. So we can just put it as 0 here. So this will be then 1 into 1 into cos 0 is also 1. This is 1. Okay. So any two like vectors, if you do dot product I dot I, right, or j dot j, right, or k cap dot k cap. So I'm sorry, all this is equal to 1. Right. So if you work with the like unit vectors, it leads to 1. Whereas if you do with the unlike things, right? For example, if it is I cap and j cap, right? So this is our I cap, this is our j cap. So if you see, they are perpendicular. I cap and j cap are perpendicular. So if you want to see multiply the component of one with the other in the direction of the other, there won't be anything. How much of this j cap is along I cap? Nothing, right? So that means this will lead to 0. Any two perpendicular vectors, if you do the dot product, it will lead to only 0 here. So I cap dot j cap, right, is equal to I cap dot k cap is equal to, right, any other unlike combinations like j cap dot k cap, right. So all this should be 0 here. Right, I dot j dot I, k dot I, right, and one more is k dot j. Right? So all this will be 0. Right? All these unlike combinations will lead to 0 for us. Right? That's what is the so that's how the dot product works here. Right, students? So we can also find the angle here. Right? If you want to find the angle between the two vectors, right, you can use dot product to find the angle. Right? Let's do one problem to understand this dot product. So what is the dot product of? Let's say, you know the verb line is given by f vector dot delta. Right? It's the dot product here, not just normal multiplication dot product. Let's do one sample problem here. Let us say force is defined this way. F is equal to 2 I cap plus 3 j cap, right, minus 4 k cap, and the displacement. Right? So sometimes it will be given directly, sometimes you have to find the displacement. Let's say here it is directly given. That charge is given directly. So let us say this displacement is just 2 j cap minus 4 k cap. Right? So this is what is the displacement. Right? So find the work done in this case. So how will you find the work done? So let's do that. So the work done is given by W is equal to F vector dot delta R. So let's do that. 2 I cap plus 3 j cap minus 4 k cap times dot product with 2 j cap minus 4 k cap. So this is what we have. Right. So now I cap, here we don't have any I cap at all. In the displacement, we don't have any I cap at all. So if you don't have anything, means it is 0 only. If you don't have that particular component, it means the value of that particular component is 0. Is equal to saying 0 I cap. Right? So that is I cap is not there, but you can try multiplying this with 2j. So what will happen with I cap and 2j cap? Okay. So you know that I cap and j cap are perpendicular. So it means this will lead to 0 here. Okay. So doing this will lead to 0. 2 I cap dot product with 2j cap will give you 0 because they are perpendicular. 2 I cap dot product with minus 4k cap also will be 0 because they are also perpendicular. Right? So any three right mutually perpendicular directions they must be perpendicular among themselves. So that must be 0. Right? Then like that we have to do for each term here. 3j cap and 2j cap. Will that be 0? Right? It won't be 0 here because it is the j cap. We are dot product with doing dot product with j cap. So that means this value is 6. 3j cap and 2j cap is 6. 3j cap and minus 4k cap. That will be 0 because j and k will be 0. Then minus 4k cap and j cap, 2j cap that is 0. Right? Because again these two are perpendicular. Minus 4k cap and minus 4k cap. So minus 4 into minus 4 that will not be 0. So that will be plus 60. So that will be then 22 here, right? And since we are finding the work done here, we can write 22 joules. Provided this is in newtons and this is in meters, we can write our final result in terms of right now. So hope all of you could hear me again. Right, so that's how we work with the dot product. Sometimes it also helps us to prove something else also apart from finding this. Right? For example, let's do a problem asked in the NEET exam. Right? This question was asked sometime like back in 2013 in the AIMS paper. So let's do that problem in 2013 question. So the question is this: if a vector 2i cap plus 3j cap plus 8k cap, I will write it on the board. If a vector, listen carefully. If a vector 2i cap plus 3j cap plus 8k cap is perpendicular to the vector 4i cap minus 4j cap plus alpha k cap, then what is the value of alpha? Okay. So what they are saying is there is a vector 2i cap plus 3j cap plus 8k cap. So this vector we have. Now this vector is perpendicular to the vector. There is one more vector 4i cap minus 4j cap plus alpha k cap. So they are saying these two vectors are perpendicular. There are two vectors defined like this, and these two vectors are perpendicular. So if these two are perpendicular, what is the value of alpha? That's what you have to find. How to find this value of alpha? Now, when two vectors are perpendicular means, right? What should be their dot product? The dot product must be 0. Two perpendicular vectors means the dot product should lead to 0. So we make use of that. Yeah. So let's call this as A vector. This is A vector and this is B vector. So their dot product must be 0. Then they are perpendicular. So let's do that. So 2i cap and 4i cap dot product will give you. So we are doing this. A vector dot B vector is equal to 8 plus 3 and minus 4. Right? Because all other things will become 0. So 2i and 2i is going to give you 8. 2i with remaining things will give you 0. So you don't have to bother about that. And 3j and 4i will be 0. But 3j and minus 4j will be minus 12. Minus 12. Right? And plus like 8k. Once again, this will be 0 for 4i and 4j. 8k and alpha k. So plus 8 alpha must be equal to 0 first. Right? Only when it is equal to 0, it means it is perpendicular. Otherwise, it is not perpendicular. So we can write this as minus 4 plus 8 alpha is equal to 0, which means alpha is equal to 1 by 2. So the value of alpha is 1 by 2. Right? That's the answer for this question. Right? So this came in the NEET 2013 paper. Likewise, problems are simple only. You just have to know what it is, right? How to apply it in problems, and you can score easily there. Right, students? And there was one more similar question also, right? Sometime back. Right. So let's move on to the cross product, right? And of two vectors. So that's the dot product, the cross product of two vectors. So if you have two vectors A and B, what is their cross product? So earlier dot product had a different meaning, right? And why first of all why cross product? So in the case of dot product, what mattered is the parallel component. Two vectors were there, right? How much of one is along the other, that only matters in the dot product, right? Like how much of this, like this is A vector means what mattered to us is how much of this A vector is along B vector, right? How much of the parallel component is there? That's what mattered in the dot product, right? But there are certain quantities which where the perpendicular component matters. The more the perpendicular component, more the value will be, right? For example, if you are going to pull a door, right? So if suppose this is the door means, right? Let's say this is the hinge and this is the door. Right? You are seeing the top view of this door. So what will be a nice way to open this door? Like let's say you are applying the force, right? I'm applying the force like this, like this, like this. So which is the best possible way to open this door? Let's say like this I'm opening, right? So this is the hinge here. It is hinged at this point. So which would be the best possible way? Which is the best possible approach to open this door? Is putting it like this. Putting it perpendicularly will give you the maximum benefit, right? You don't have to spend too much work there. Instead of pulling it this way or this way, you have to spend more work. Right? So there are perpendicular components which matter in certain quantities, like, and here that is where the cross product comes into picture. The cross product. So according to this, the cross product of A vector and B vector. Let's say these two are the vectors, A vector and B vector. So when you do the cross product, you will get one more vector. Right? Unlike the dot product, the the outcome is also a vector here, and that vector will be pointing in the direction. The direction of that vector will be perpendicular to both A vector and B vector. Right? So that is what is the definition for the cross product here. So A vector, let us say I am doing the cross product like this. A vector cross B vector like this. Right? So then this leads to the third vector, which will be like this. So this C will be perpendicular to the plane formed by A vector and B vector. Right? Suppose if let's say this is the book I am having here. Let's say the A vector and B vector both are right. You can imagine these to be like, or I will demonstrate with this angle itself. Let's say this A vector and B vector like this. Right, friends. So these two are, let's say this is A vector and this is B vector. Right. So now this, like doing a cross product will lead to the third vector, and how the third vector will be is it will be in the direction perpendicular to both A vector and B vector. Right? So if I am doing A vector cross B vector, the third vector will be like this. Right? So A vector cross B vector. Right? This is A vector cross B vector. The third vector will be like this. Right? It will be perpendicular to both A vector and B vector. Right? And suppose if I am doing the opposite operation, I am doing B vector cross A vector. This is B vector cross A vector means then the third vector will be like this. Right? It will be perpendicular to this. Right? So that's what is this cross product here. So it will result in one more vector which is perpendicular to both the vectors. Right, friends? So this is then A vector, we can write like this: A vector cross B vector is equal to C vector here. Right? It leads to the third vector, right? Which is perpendicular to both the vectors. The C will be perpendicular to A and B as well. Right? And what is the magnitude of C? That is another question. So it can be written as the magnitude of C is equal to is given by A vector, magnitude of A, magnitude of B, right, and sin theta. This is what gives the magnitude of this third vector. A vector, magnitude of A, magnitude of B into sin theta. Remember, theta is always the smaller angle between A and B. So that means there is no way that theta can be beyond 180 degrees. Now, if theta is not beyond 180 degrees, you are doing only sin theta, it will always be a positive value. Right? Sin 0 is 1, sorry, sin 0 is 0, then up to sin 90 it goes to 1, then it will once again comes back to 0. Right? So always this quantity will be a positive quantity here. These two quantities are also positive, hence this also will be positive. So the magnitude of this vector is given by this. This A magnitude of A, magnitude of B into sin theta. Sometimes we can also write like this: C vector is equal to magnitude of A, magnitude of B, sin theta into n cap. You have to put an n cap there to take care of the direction. This n cap is the unit vector along direction of C. This is another representation here. N cap is unit vector, right, along C vector. Right, n cap is the unit vector along C vector. So that is what is the definition of cross product. Right, students, and as you see here, one property that was applicable in dot products will not be applicable here. That is, there we saw in the dot product A vector dot B vector is equal to B vector dot A vector, but that is not the same case here. Suppose if you do B vector cross A vector, then you are right. If I am doing the opposite, this is A vector cross B vector means if I do the opposite here, right, B vector cross A vector, then it will be pointing downward here. Right? B vector cross C vector will be A vector will be pointing downward. So that is where we apply this right hand rule to determine the direction of the third vector. We apply this right hand rule. So A to B means you build it like this. Let's say A is coming out of the board like this, B is going inside. Right? It's difficult to see here, but let's say this is A and this is B. B is like this. Right? So from A to B, if you go this, the thumb indicates the direction of the C vector. Right? But from B to A means like this will be the direction of the third vector. Right? It's like opening your water bottle like with your right hand. Right? It's like whichever way you are going that you can. Right? Suppose if I am close, right, you have a water bottle. If you turn it like this, if I am turning the water bottle like this, right? So I am doing it from A to B. That means the water bottle actually opens, the cap comes out. That is the direction of the third vector here. Right? In this case, the cap closes, it goes down. So that's the direction of the third vector. Right? Right. So let's then continue the properties of this cross product. So unlike the dot product here, A vector cross B vector is not equal to B vector cross A vector. So these two are different here. A vector cross B vector will give you one result. B vector cross A vector will not give you another result. Right? And so what are the other properties here? Now, how to work with the unit vectors here? Now there I dot I, the parallel component matter there. So it was like we had one the parallel components. Here it is slightly different. We do it like this. Right? This is a bit easy for us to work. I, J, K. Right? So we put it like this. Right? So then we can do this easily. I cap into J cap is equal to K cap. I vector cross J vector is equal to K cap here. Right, so that's because of this only. Right? You know that this is the direction of I cap, right? And this is the direction of J cap, and this is K cap. Right? So for example, if you're doing I vector cross j vector, I'm rotating it like this. I'm rotating from I to j here. So when I'm rotating from I to j, okay, it's the right hand rule here. Just imagine you are turning the right hand screw like this from I to j. So that will only come out of the board, right? Okay, so I to j, when you rotate like this means it will come out of the board. When you rotate from j to I, that will go into the board. Right? You can always imagine like this. Right? You have a right hand screw in your hand and you are turning that screw. Right? So when you have the screw like this, if you turn like this and turning it like this, so this screw will only come out here. That is the direction of this third vector. A cross j is A. Right? Then you can proceed like that. J cross, right? That's where this will be helpful. J vector cross K vector is going to be I vector, right? J cross K. So suppose if I do this means it will go in the I direction. Right? Similarly, K cap into I cap is equal to J cap. K cap into I cap is equal to J cap, like this. Right? It will come in the upward direction like this. Right? Just the opposite of this is also true. That is, if you do J vector cross I vector is minus K cap. Sorry, K cap into J cap is minus I cap. I cap into K cap, it is minus J cap. Right? So opposite is also true here. Right? So that's how we have these values here. At the same time, if you do the like things like I cap cross I cap, that will be 0 here because they are in the same direction. Right? Here it is the, according to the definition itself, it is sin theta. Sin 0 is 0 for us. So when you do I vector cross I vector, it is 0. Right? Similarly, J vector cross J vector is also 0, and K vector cross K vector is also 0 for us. These are the things that you have to remember in cross product. Right? So finally, we will do a problem in this cross product, right? And we will write it in determinant form. So one way is like writing this cross product in determinant form helps us to solve the problem. So we'll do one problem and we'll wind up for today. So how to solve a problem using this cross product we'll see now. Let's say A vector is given by 2 I cap minus 3 j cap minus k cap, right? And B vector is given by I cap plus 3 j cap minus 2 k cap. So find A vector cross B vector. That's the problem. Find A vector cross B vector. So how to find it? Right. So one way we can do that is we can put everything in the determinant form. That is, we are going to write it like this: A vector plus B vector is equal to, right? So I cap, J cap, K cap. We are writing A vector and B vector in the determinant form. So this is 2 first A, because we have to do A cross B, not B cross A. So you have to write first A only here. So 2 minus 3 minus 1, and then B, which is 1, 3, and minus 2. So write these things in the order A cross B in this order. This order. Right. So now, how to continue further? Right. So first, I cap into. Right. So you have to multiply this number with this number, and then subtract the product of this number with this number. Right. So multiply these two, and then subtract what you get from these two. So when you multiply these two, so minus 3 into minus 2. What is minus 3 into minus 2? That is 6. So you write 6 here. Okay. What is this one? So 3 and minus 1. That is minus 3. So that means it will be minus of minus 3. So you have to subtract here. So you're writing like this: minus of minus 3. Right. So plus j into. So for this j alone, we have to do in a reverse, in an alternate way. That is, you won't be doing this first. Instead, right, you leave this minus 3 and plus 3, right? Minus 1 into plus 1, right? You have to do it in the opposite way for this one. So that is going to be minus 1. Then it should be this first: minus 1 into plus 1, and then 2 into minus 2. So 2 into minus 2 is minus 4. So minus 1 minus 4. So this will be the second term here, plus k into, plus k cap into, right? I hope all of you can see this, plus k cap into. Here we can do the normal way itself. Plus k cap into, first is this 2 into 3, which is 6, and then this, so minus 3. So 6 minus minus 3. Right? So all this we have to simplify further. So when you simplify this means 6 minus minus 3. What is that? That is going to be 6 plus 3, which is 9. So we get right here, you get 9 I cap. Right? So 9 I cap. This is minus 1 minus minus 4, which is plus 4. So minus 1 plus 4 is plus 3. So plus 3 j cap. Right? And this is minus 6 minus of minus 3, which is plus 9. So plus 9 k cap. Right? So this is what is our answer. So this is what is this thing. A cross B is given by 9 I cap plus 3 j cap minus, I'm sorry, plus 9 k cap. So that's how we do the cross product. Right, students? So sometimes they like the cross product of two, like how will you prove two vectors are parallel? So two vectors are parallel if their cross product is 0, right? And just like perpendicular vectors, when two vectors are perpendicular means their dot product must be 0. When the cross product is 0 means it means the two vectors are parallel. In that case, the cross product will become 0. For parallel vectors, cross product will be 0. Right? For perpendicular vectors, dot product will be 0. Right, students, I hope all of you understood so far. Now, one more rule I will tell right before we end, which will be right highly useful in solving the problems. That is called Parallelogram Law of Vectors. What is it? We'll see. Right, I'll erase this. Parallelogram Law of Vectors. So what this law says is, right, if you want to add two vectors, right, let's say you want to add two vectors, A vector and B vector. This is A vector and this is B vector. So you know, like we have done in geometry itself, the addition will be should be from the tail of the first vector to the head of the last vector. So this gives the resultant vector, which is R vector. Right? So now according to this law, what it says is this resultant is the diagonal of this parallelogram. Suppose if you are forming a parallelogram here, okay? So this vectors can be put anywhere in space. This is B vector, okay? And this is A vector like this. So this and also the order of addition doesn't matter. A vector plus B vector or B vector plus A vector. So it's the same thing. So this the diagonal gives the the resultant of the two vectors. Right? And we provided here we are taking this theta as the angle between the two vectors A and B. So we can write down it this way. I'm not doing the proof here. It just we can prove it also. It's not a very big deal. That is, this resultant can be. So this is also angle theta. So this resultant is basically so this is B cos theta and this is B sin theta. So this quantity is the cos theta, and this from here to here is the sin theta. So this r vector must be, this r is the sum of, like it must be the square of the sum of these two here. Right? We are applying again Pythagoras. So from here to here, whatever is the length and this length, so this is perpendicular here. This resultant must be the like this square plus this square. That must be equal to resultant square. So we do that here. So r square is equal to a plus, right? This is a. From here to here it is a. This is b cos theta. A plus b cos theta the whole square plus b sin theta the whole square. Okay? So when you do this means, right? So when you do this operation, I'll keep like this. When you do this operation, you will get r square is equal to a square plus b square cos square theta plus 2ab cos theta, right, plus b square sin square theta. Now you know that b square cos square theta plus b square sin square theta is 1 here. Right? So this must be 1. This must be 1 for us. So that means you can write this as a square plus b square plus 2ab cos theta. Right? So that is what is this r square. So this gives the resultant of the two vectors here. Okay, so this law we call the parallelogram law of vectors. Sometimes like in problems this will be highly helpful, right, applying this law. Right, and this theta is the angle between the two vectors here. So let's quickly solve one problem because it was asked to be one of the previous years. Let's solve one problem, right, and then we'll wind up for today. Right, so the question is this. Yes. So the question is this: the angle between two vectors of magnitude. The angle, like can take out this question. Angle between two vectors of magnitude 12 units and 18 units. They are giving two vectors here. The magnitude of the two vectors, let this vectors be a vector and b vector. So magnitude of A is 12 units, and magnitude of B is 18 units. They have given these two numbers here. Magnitude of A is 12 and that of B is 18. Next one. So the resultant is given 24. The magnitude of the resultant is 24. Right. So these three values are given. Now you have to find what is the angle between the vectors. So for such problems, this is the best way to find, right? The way in which you see this parallelogram of vectors. Right? We can just apply this formula. The resultant square. The resultant square is going to be 24 square is equal to a square, that is 12 square, right, plus b square, which is 18 square, plus 2ab. So 2 into 12 into 18 into cos theta. Like this we can write. So the r square, the resultant square is r square, that is 24 square, a square is 12 square, b square is 18 square, and 2ab, a is 12, b is 18, cos theta. Just substitute there. Let's just simplify this, we will get theta. So if we simplify this means it will be 24 square is 576 is equal to 142 plus 324 plus 2 into 12 is 24. 24 into 18 is, so what is 24 into 18? So that must be 24 times 18, 480. So that must be 432. Right? 24 times 1854 32 cos theta. Next one. So it is this we are getting. We simplify this. Simplify this means so 144 plus 324 is 468. So 432 cos theta is equal to 576 minus 468, which is 108. Right. So we can cancel these things. So this will become 4 here. Right. So which means cos theta is equal to 1 by 4 here. We get cos theta is equal to 1 by 4. So which means what is the value of theta? So theta is equal to cos inverse of 1 by 4. So that will be the answer here. Next one. So that's how we find these things out. Right. So theta will be cos inverse of 1 by 4. That we cannot like tell immediately, right, because we need some calculator to work this. But that's how we use this parallelogram law of vectors. It says the resultant square is given by if two vectors are right there, if the angle between them is theta, then the resultant square is given by a square plus b square plus 2ab cos theta. Next one. So that's what is this vectors, right? And so the next day we'll move on to the right. Tomorrow I think we have another class. We'll move on to the next topic. Right? Just make sure you revise these rules, right? And you can solve some practice problems on this, and can get back tomorrow. Right? So I'll end this session for today then. Right? Bye then, and we'll see you tomorrow. Bye students.